In this episode of Energy Talks, we will discuss the importance of performing periodic, offline partial discharge measurements on power transformers used in wind parks, particularly dry-type transformers. We will address what you need to consider when performing these measurements and how to easily deal with challenges in the measurement environment. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone. Welcome to Energy Talks. Onshore and offshore wind parks utilize different types of power transformers. Periodic diagnostic condition assessment of these transformers is becoming increasingly important to wind park operators. This is because failures are causing increasing outage costs for repairs and, in the worst case, undelivered energy. The assessment of the insulation condition of, for example, Cast-Resin, also known as dry-type transformers, is therefore essential. Joining me to discuss the importance of performing periodic partial discharge measurements on wind turbine transformers and how to overcome the related measurement challenges are Christoph Engelen and Dr. Alexander Kraetge. They are both Omicron PD testing experts, and they have direct experience with the on-site PD testing of transformers in wind parks. Hello, Christoph. Hello, Alex. Welcome to Energy Talks.
Thank you very much for having me.
Thank you for having us, Scott.
Well, thank you both. Alex, let me start with you. First of all, different types of power transformers are used in wind parks. Could you please describe what these are and what they are used for?
The transformers in wind parks have different functionalities. The larger units connect a set of windmills to the grid via a dedicated substation, while each windmill unit itself also needs a transformer to connect to the bus feeder. So there are different sizes and different types of transformers.
More specifically, what are cast-resin transformers, also known as dry-type transformers? For example, what function do they have, and how are they different from other types of transformers used in wind parks?
So transformers in general transform voltages to another voltage level. That's something that all transformers do. And for cast-resin transformers, they do not have a vessel which is filled with dielectric liquid like ester or transformer oil, but there is a solid block containing the windings and the insulation. And the challenge of that is that the heat which is generated by losses from a transformer has to transfer it away from the transformer, which is a little bit more tricky than with oil, because oil is it's easier to transport heat with the oil.
Okay. All types of transformers used in wind parks are influenced by factors that can eventually cause failure. Alex, what are these factors, and what is the most common cause of failure?
The transformers in wind parks see very specific stresses, depending also where in the station the transformer is located. Another cause of problems in these kind of transformers can be steep voltage rises from rectifier influences and also DC offset. So there is a large variety of stress which are applied to these kind of transformers, and that's why they are designed for that. But even though it seems that the failure rate for a few of these transformers is higher than normal.
Alex, to avoid failure, different diagnostic tests are periodically performed on transformers. Why is partial discharge testing so important, and when should it be performed?
The difference between oil-filled or liquid-filled transformers and dry-type transformers is that the first named kind of transformers is quite easy to assess, because normally you take an oil sample and then you can analyze that, and that tells you a lot about the health of the unit, and then you can do more accordingly tests which are based on the first analysis of this insulation liquid.
Mm-hmm.
You don't have these possibility for dry type transformers, and that's why the normal tests that you can do, this is not that much. You can check the ratio of the transformer, you can check the winding resistance, but typically these are not that much affected by problems that may occur for wind farm transformer applications. And due to these cracks that may be caused by these constant vibrations, these you cannot really assess them with the normal typical winding resistance or FRA test. And the only thing which is possible to be used as a, let's say, pre-warning tool is the PD measurement. So you make an induced measurement, an induced voltage test, and then you can look for, let's say, signs that there is an approaching failure. And that's why this is more or less the only early warning tool that you can have for that kind of transformers.
Interesting. And when are they generally performed? How often should they be performed, the partial discharge tests?
There is no easy answer for that. So one of the typical things is if you have a set of windmills and one or two of these transformers show failure or failed already, then it absolutely makes sense for sure to test more of these transformers, because normally they are ordered as one batch. And if you have a transformer failure in one of those, then you should also investigate the others.
Okay.
But there is no general rule for applying a PD test. This is something that haven't been done that much before, because it's the older, let's say, traditional dry type transformers haven't had these kind of additional stresses, and that's why the failure rate was quite low, and that therefore for years these kind of tests haven't been performed.
Do you tend to see an increase in the need for partial discharge testing on these types of transformers in wind parks?
I think so. This is obvious. I mean, it depends on the manufacturer of the transformers, of the windmill, on the commissioning companies. But typically, these commissioning companies, they are on the mechanical side, because there's so many things that have to be taken care of when assembling the nacelle and everything. And the transformer is just a part of it. And normally they said, okay, this is a maintenance-free transformer, because it's more or less it is maintenance-free, especially these Cast-Resin units. And nobody's really taking care about these. And I think that there's not that much experience also with how these transformers deal with let's say salt fog and salt on the surfaces, and what this makes with the transformers and with the insulation material on the outer side of it. That's I think there's an increase of that, because we are all still in a learning phase,
especially in the area of wind parks, I would assume.
Yes, yeah. I mean, one of the things is you can place, as said before, the transformer on different places in or outside next to the wind tower. And then you can have liquid-filled or dry-type transformers, and all these combinations are possible, and we still learn what's the most optimized way to be as cost-efficient and reliable as possible.
Well, thank you, Alex. Christoph, I would like to ask you a few questions. First of all, how is partial discharge testing generally performed on transformers in wind parks? Is it different than transformers in substations?
Well, it depends. So the very first thing you need is a proper HV source, so high voltage source, to generate the test voltage for the PD test.
Okay, so we're talking offline testing then.
Right, most of the time it will be offline testing. Okay. And for typical, or let's say for bigger power transformers, the HV source is, for example, can be on a truck and is a powerful source to deliver the required energy.
Mm-hmm.
But if we are looking at smaller units, and smaller in terms of power rating means a couple of MVA, that's also the kind of transformers we're looking at in wind power plants. There's another method, which is the induced voltage test, and that's something Alex already hinted at.
Yeah.
And for this case, we use, for example, our CPC, where the test voltage is actually applied to the LV terminals of the transformer, and the transformer itself generates then or induces the test voltage, the high voltage, on the HV terminals. This means you don't have to have this bulky big source to energize the transformer, but you can rather use a smaller and portable source. And especially for wind power turbines, this comes in handy because there we are often dealing with limited spaces, confined spaces, and the accessibility is quite hard, especially if the transformer is mounted in the nacelle, for example.
Yeah. What is different when performing partial discharge measurements on cast resin or dry type transformers?
Right. So this method of induced voltage testing can, of course, also be applied to oil-filled transformers or cast-resin transformers. So there is not much of a difference when it comes to the setup and the general procedure.
Mm-hmm.
The major difference for cast-resin transformers is that we have much stricter limits in regards to the permissible PD activity. So if you're looking at the standards and the factory acceptance test, the IEC allows only 10 picocoulombs, so 10 PC, to pass the test. And for us in the field, on the one hand, we are currently lacking a standard or a guideline. But if we stick to this limit of 10 PC, this means we have also lower tolerances regarding noise. So we have to make sure that the noise level is reduced and in a acceptable level, that we're not blind in this range of 10 PC, that we can actually assess the condition of the cast-resin transformer.
Okay. What are the challenges faced when testing PD on these types of transformers?
Well, on the one hand, as I mentioned, the noise is, as for all PD measurements, always a problem. So noise means electromagnetic interference, typically originating from, for example, power electronics close by, like inverters, rotating machines, or any other machinery.
Mm-hmm.
So one issue is that we need to bring these levels down as much as possible, so that we don't have an overlay between noise and actual PD signals. That's something which is a kind of a issue for all PD testing, so I wouldn't say this is very specific to cast-resin transformers.
Uh-huh.
But in addition, we also have this issue of energizing the transformer. So we need to have a power source which is powerful enough to energize the transformer. So here we have to have a look at the, for example, no-load losses of the transformer, that we can make sure that our source is actually powerful enough to generate the test voltage. And then, especially for wind turbines, as I mentioned, this limited access is, of course, always an issue. So if the transformer is mounted in the nacelle, as Alex mentioned, we have to operate very limited spaces and still make a suitable HV high voltage setup with all the permissible distances to all the surroundings.
Okay. How can these measurement challenges on cast-resin transformers be best overcome?
In terms of noise reduction or electromagnetic interference, of course, it's ideally always the best choice to, let's say, switch off or to get rid of those noise sources. This could be, for example, if you're looking at power electronics, to switch those units off. That's also one advantage of doing an offline test. Then you are physically disconnected from the grid and also from other machinery. Or you could schedule the measurement for a time where you know that there's less activity. But obviously, this is not always possible, so we have to find other ways to reduce the noise. One option is to adapt our setup. So normally, you want to have the connection cables as short as possible, so that those cables do not act as an antenna, and make it as noise-free as possible. And then, as often, there is still some noise coming from the surroundings. So we have different software and hardware solutions in the MPD software, for example, which can help to either filter out some noise momentarily or block it completely from entering our test setup.
Mm-hmm.
So there we have different options to deal with noise. And the other challenge which I mentioned, which is the power supply and the power intake of the transformer. Typically with the CPC100, which we use, we already have a quite powerful solution, so we can energize transformers up to 4 or 5 MVA, which is in the range of typical transformers in wind power plants, I would say. But even if we need more power, we can synchronize up to 3 units, 3 CPCs, so that's the CPC sync approach. And there we can operate 3 units or up to 3 units in parallel or series. And then we get energized transformers with power ratings up to 15 to 20 MVA, depending on the design and the construction of the transformer.
Okay. Well, thank you, Christoph. Coming back to you, Alex. For the offline PD measurements you and Christoph have performed on Cast-Resin Transformers, which testing equipment did you use? Now, Christoph had mentioned the CPC 100 for energizing the asset. Could you please describe the complete testing setup? What other types of equipment were used?
In addition to the CPC Christoph mentioned, we need typically an adaptation transformer. We developed an adaptation transformer, which is especially suitable for these typical voltages of the low voltage side of wind farm transformer. Typically is around 700 volts.
Mm-hmm.
And these kind of transformer is then as the adaptation transformer is connected to the transformer, to the asset and the test itself. And for measuring PD, we also need to have a coupling capacitor, which is a medium-sized transformer for depending on the voltages between 38 and 50 kV. And then we use the MPD 600, or in the newer times, mainly the MPD 800 for measuring the PD.
Very good. Can this same testing equipment be used in all phases of the transformer's life? For example, from factory testing to commissioning and troubleshooting in the field?
Yes. Yes, it's typically the MPD 600 or 800 is very, very widely used in all transformer manufacturing sites at all around the globe.
Mm-hmm.
And also the CPC is a well-established test equipment for transformers in field as well as in the factories. And one of the advantages, and this was also initially one of the pushes towards this direction in using the CPC as a power source for an induced test, was that a lot of manufacturers and servicing companies already do own CPCs, using it for winding resistance measurements, for example.
Mm-hmm.
And then there is just adding a function to an existing equipment and just using this additional adaptation transformer, and you have much more possibilities to use the equipment for additional services, and that's a quite well-established procedure in the meantime. And it is because you don't need that much additional budget to buy another external power source. You can use what you're already using for various other tests.
Very good point. Okay. How in particular did the MPD 800, you had mentioned also MPD 600, how did both of these PD measurement devices help you to greatly minimize or eliminate the effects of noise in the testing environment?
It's a good question. Thank you. The point is that the MPD 800 already, each unit contains of 2 measurement channels, and one is the normal measurement channel, and the other one can always be used as a gating channel for external hardware gating. And that is that's a difference to the MPD 600. So in each MPD 800 contains initially the capability to connect a gating antenna onto it, and that makes it easier because you don't have additional equipment to it. I mean, if you go for wind farm testing, the portability of the equipment is always one of the key factors, because they are in remote areas. I mean, you need to have a lot of wind and not too many people close by, which are not happy with seeing that wind tower. So you need to have a high portability. And if you also go up into the nacelle, typically even then, if there is, especially for the larger ones, there's an elevator, but also then this is a quite narrow thing, because everything is space optimized. And that's why these small portable units, battery powered without the need of additional equipment is of utmost importance.
Thank you, Alex. Christoph, the following questions are for you. How is the partial discharge measurement data generally displayed, for example, from the MPD 800?
Well, in this case, the good point is the PD data is generally displayed always in the same way. So it doesn't matter if you're looking at Cast-Resin Transformers or cable testing or anything else. So one very well-established method is the so-called PRPD pattern or PRPD diagram. And the idea is that whenever you have an impulse, you record the impulse itself and also the phase angle of your voltage. And then you can place in a so-called histogram this impulse at the exact phase angle of the voltage. And overall, you will end up with a certain pattern, which is unique to different PD types. So this helps you a lot to characterize your PD source and the type of PD source actually. And this can be is very helpful actually when you're talking about criticality. What kinds of PD types do you have or which are active? So this helps to analyze how critical is actually the defect. Then you can look at the PD development over time. So either during a measurement, if the PD increases or decreases, or also do some trending, for example. We talked about limits which are given in the standard. So they are talking about absolute discharge levels in picocoulomb. So this means if a standard tells you not more than 10 picocoulomb are permissible, then you're just looking at one number basically, and you can compare if it's above or below. This is fairly simple and also prone to some errors, but it's quite easy to apply. And another quite important factor from my point of view are the inception and extinction voltages. So you can check at which voltage your PD activity starts. And then again, when you decrease the voltage, you can check when the last PD activity stops. That's also the advantage of an offline test, that you can control your test cycle and the voltages. And this helps you a lot to analyze if my PD activity that I'm looking at during an offline measurement is actually active during normal operation, because I'm currently testing the transformer when it's out of service, so I need to know how it behaves when it's switched back on.
I have a quick question in addition to that. Is there any opportunity or any time when you would do an online PD measurement, or are we strictly speaking about offline measurements only?
Online testing is an option. So far from our experience, it's rarely done. The main disadvantage is that you have to deal with a lot of noise. And as we said, noise is quite a sensitive topic in this regard. So if you have a way to get rid of the noise, or let's say filter it out, it can be quite helpful. For example, if you do an offline measurement and you maybe see some PD activity, but you don't want to take the transformer out of service right away, you could, for example, install like a monitoring or temporary monitoring system, measure the PD activity using, for example, the cable grounding, and just check how the PD activity develops over time to get a better feeling, let's say, for the activity in the transformer, and check if the activity stays constant, then you might keep operating the unit, or if it increases, you could pull the plug basically on the unit and replace it.
Okay. Now for the offline measurements, just to clarify, you definitely need to have everything down in that particular turbine Are there scheduled maintenance periods when these offline tests are performed?
Well, there are typically maintenance plans in place. So, from my understanding, you wouldn't take out a unit just to perform one test. So this PD testing also lends itself to be incorporated in such a maintenance plan that you can just add it as a new working point, let's say. The intervals, I would say, depend strongly also on the operator and their workflow and how often they would like to maintain the units.
Okay. What does the partial discharge measurement data tell us about the state of insulation condition in transformers? What are you looking for, and what are the indicators for taking corrective action?
So the main reason why we're looking at PD results or PD measurements is that we're lacking some of the typical diagnostic tools for insulation condition, as Alex already mentioned in the very beginning. So typical tests like DGA, which is used on oil transformers, is not applicable here. So we need to have some sort of substitute basically to get some information on the insulation condition. And on the one hand, if you do this measurement and you're only looking at, let's say, the absolute PC values or the picocoulomb values, you could compare it to the values or to the limits given in the standard. But from my point of view, this doesn't give you the correct picture or the overall picture. So on the one hand, you need to identify what type of source you have, which means if you're looking at a Cast-Resin transformer and there are some, for example, there's some pollution, some grease or dirt on the surfaces. This could lead, for example, to surface discharges. Also, Alex mentioned before that you could have some moisture in the nacelle. Also, everything which increases the conductivity on the surface will lead to PD, and the corrective measure in this case would be to clean, for example, the winding. So this is maybe not as critical. And can be corrected. On the other hand, if you have, for example, PD which are located inside the winding body, so inside the solid insulation because of some voids or some gas filled caverns, then it's close to impossible to correct this because you can't correct this anymore. Then you can only start to trend maybe the results and see if the PD activity develops, if it increases. And for me, another important point is to check really the inception and extinction voltages to really make sure at which level is the PD actually active. If it's only active above the nominal voltage and not during normal operation, you might want to keep an eye on the transformer if the situation deteriorates, let's say, the condition of the insulation, but it's less critical compared to a transformer where it's already active during normal operation.
Okay. Well, thank you, Christoph. Now I have a few questions for both of you. What do you see as future trends and challenges for wind parks, especially in the area of asset condition assessment? Alex, what do you think?
The point is that the transformers so far are not really prepared for being tested in the field with PD testing. These are quite, the construction of these type of transformers is quite similar to the normal industrial transformers or transformers for marine and ship applications. So there are no, let's say, possibilities to use corona rings or anything that may reduce the interference or let's say to reduce the noise surrounding your measurement. It could be that let's say the owners of wind parks, if they experience increasing numbers of transformer failures, which not the transformer failure is the big thing, but the loss of not delivered energy. This is much more than the value of the transformer itself. Then it could be that they demand more possibilities to test the transformer, that would also lead to questions regarding the size of the nacelle, or let's say internal structures inside the nacelle, so that it is easier possible to test that kind of transformers. But that must be driven by the owners of the wind farms itself. But that could be something. And another thing is for sure that they need more people which are able to perform under these challenging surrounding conditions PD tests.
Mm-hmm.
So that's a question of having internal or external expertise, but this is for sure a question for the future.
Okay. Christoph, what do you think?
Well, from my point of view, one topic is also the influence of inverter impulses, as already Alex mentioned before. So this is not a topic restricted to wind power plants, but it will be, or is a challenge probably for a lot of different areas. And the question which is widely discussed, how does, for example, how do steep voltage impulses affect the insulation condition of high voltage equipment? And these transformers are also working with inverters. So that's for sure one of the challenges. And in terms of future trends, I would like to see some increase in the online measurements, or would be very interested in see what kind of possibilities we have to perform actual online measurements and bring down the noise so that you can do actually meaningful PD measurements. Could be a very, let's say, basic monitoring system, because as we heard, the cost of the transformers is not that high. So it could be a basic one, just giving you some indication if there's some activity, and then you could follow up with a more advanced measurement. So online trending would be a very interesting topic in this regard from my point of view.
Okay. So if you do detect something with the online trending, you can go in and do a diagnostic offline PD measurement to pinpoint the cause and a potential problem.
Right, and this would also help you to, for example, prioritize for the maintenance schedule, so that you could maybe prioritize different units depending on their estimated condition, let's say.
Okay. How will partial discharge testing play an increasing role in the condition assessment of transformers in wind parks? Alex?
As it is one of the methods to assess the health of the condition, the health of the asset for dry type transformers, or let's say for cast-resin transformers, better to say. This will be one of the major performances to be measured. So I mean, the PD measurement for sure will increase its importance for the on-site assessment of dry type transformers. For the liquid filled transformers, it's a different story. It's there is mainly the increased use of high temperature materials in the insulation and in the liquid is a topic to increase the performance of those units. But in this case, the PD measurement is of much smaller importance.
Okay. Christoph, what is your opinion?
Well, I agree. I think the PD measurement is an important tool, especially since we are lacking some of the most important conventional tools, let's say like the DGA or also dissipation factor measurement, which can be applied to this kind of transformer, but is also affected by external factors, also the surface condition of the transformer. So it's not, let's say, as reliable as we are used to be, as it is from oil-filled transformers. So from my point of view as well, the PD measurement is a very important tool here. It would be nice if we can, let's say, bring down the complexity of the test to make it as easy to perform as possible, so that you can also test more units in a shorter time. But I think this will be some of the challenges of the coming years.
Do you have any tips for how engineers can best prepare for the increased need for PD testing? What is something that will help them save time and effort when performing these measurements? Alex, what do you think?
One of the key points for preparation, in my opinion, is to have a lot of possibilities for to provide shielding electrodes or material that can be used as shielding electrodes. There must be some flexibility. Another point is to document best practices with pictures. So it's very hard to learn, and it's a hard way to learn how to get one transformer ready for testing without, let's say, bringing additional noise sources into the measurement the circuit while performing the induced test. So if you found a possibility there, then you should document what were the measures to increase the learning effects and to share knowledge. I mean, this is quite tricky because the current construction, even if the transformer stays next to the base of the tower, even there are surroundings, there are grounding rods and everything. It's very hard to get the transformer up to the necessary voltage without introducing additional electromagnetic interference into that. And if you learn how to do it, that's something which should be documented and shared and discussed within the community.
Definitely. Christoph, what is your opinion?
Yeah, I agree. To my knowledge, there is currently no standard or guideline, for example, taking care of those on-site tests on these kinds of transformers. So whenever we are doing measurements, we try to stick to the recommendations from the ISC, which is directed at the FAT test. But what I think helps is to have a clear set of, let's say, objective rules, how to assess the conditions, so that you have always the same assessment rules. Also clear communication with operator, for example, on the test cycle, because if there is no guideline, it makes sense to communicate what voltage levels and what duration of the test cycle should be tested. And then from a practical point of view, of course, it makes sense to be familiar with the capabilities of, for example, the MPD software in terms of noise filtering, separation of PD clusters, and all these kinds of tools that we have, which will make your life much easier if you're on site and dealing with those problems.
Okay. Alex, where can our listeners get more information about PD testing on transformers? For example, cast iron or dry type transformers?
We published several papers on or typical conferences together with Christoph very often. For example, we discussed this topic on the Stuttgarter Hochspannungssymposium a few years ago. We also had this topic at the TLM. This is a Transformer Life Management Conference in Germany. But we also had publications in other countries. We recently had it as a cover story of the NETA magazine. The NETA is the International Electrical Testing Association in the US, which is also quite prestigious. And on their quarterly magazine, we discussed this very broadly, and we are very open and to discuss this with other peers and colleagues, and we are also happy to exchange best practices and the knowledge about it. And there are a lot of possibilities to learn more about it. For example, also in an article on the well-known Transformers magazine.
Okay. Christoph, are there any webinars or training courses offered by Omicron Academy about PD testing on power transformers?
Well, yeah, there are webinars and also academy trainings, on the one hand on power transformer testing, so in general, to get a better overview, let's say, on all the available diagnostics. And we have a wide range actually of PD testing courses for various assets, and of course also including power transformers. And then we could also discuss the special case of testing Cast-Resin transformers using induced voltage tests. If somebody's interested, for example, in really looking in detail into this topic, then we can also have like a customized training on this specialized topic as well.
Okay. Very good. Christoph and Alex, thank you both very much for joining me for this discussion.
Thanks for having us.
Thank you very much, and have a great evening, Scott.
Thank you. And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, including, of course, partial discharge testing and monitoring, and it offers you the matching solution for your application. For more information about our testing solutions, as well as online courses and webinars offered by Omicron Academy, please visit our website at omicronenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.